learning goal is I can graph a line using slope-intercept form. There's more than one way to graph a line. You've already used a couple of ways. One of those ways is you can make an XY table. You can pick X values, substitute them into the function rule, and get your Y value, and then you have ordered pairs to help you plot points on the graph and get your, the graph of your linear function. You've done that. The other thing you've done is you've used the X and Y intercept method. You call the X-intercept, the Y-intercept, those 2 points. It only takes 2 points really to graph a line, once you get the graph for a line. So you have used the X and Y-intercept method for graphing also. Now we're going to do using the slope-intercept form. So a linear equation solve for Y. So in other words, as they were in yesterday's notes, this says exploration because I think last year we did some sort of an exploration. So as they were in yesterday's notes, is considered to be in slope-intercept form. And just a reminder, slope-intercept form, you will use that forever now in your math classes. You need to get it to memory. Y equals mx plus b. Okay? No.
I don't have a copy.
Okay, so what is m representing in that equation? The slope. So m is the slope. So once the equation is solved for y, whatever x is being multiplied by tells you what the slope is, and b is the what? The y-intercept. And the constant that is being added to the x term is the y-intercept. So slope-intercept form is the most common way, typically, that you will use for graphing a linear function. And then the x and the y, those just stay x and y because we have several ordered pairs that can be put in for x and y, and they should make the equation true. So if you know the slope and the y-intercept of a line, you can easily graph it. Graph the line whose slope is 2 and y-intercept is -3. So basically they're telling us here that the slope is 2, so what would that be? Our what? Our y, m, x, or b? That would be our m. What would the -3 be? That's the y-intercept, so that's what? That's that in our y-intercept form, and if we have to write the equation, we can substitute that in for the b. Right now, we're just going to use it for graphing. So start by plotting the y-intercept 0, -3. So that's what you always start with when you're using slope-intercept form. You go to the y-axis and you graph your y-intercept. So ours is -3 for this one. So we're going to put a point there. Now hear me on this. When you use the x and y-intercept method, you can get by with just doing 2 points. When we do the slope-intercept form, I'm setting a standard of a minimum of 3 points. You can make more, you can make less. So 3 points is your minimum that you're going to use to help you get a good graph for these, okay? So from that point now, we use the slope to plot more. Well, if the slope is 2, remember slope is rise over run. So we can put it over 1 to make it into a rise over run. Any number, if it's not a fraction, can be made into a fraction by putting it over 1. So now we have our rise over run. But then I also say, we could also state it this way, -2 over -1. Because what's a negative divided by a negative? Positive. So that would still represent a +2 slope. So sometimes you can rename slope and use it 2 different ways rather than just the one. So we're going to go back to our y-intercept. We're going to use the rise of 2, which means we're going to do 2 what? What does that 2 tell us in a rise? What should we do with that 2? Go up 2, and what should we do with that 1 that's the run? Go over 1. So we'll go up 2 and over 1, and we'll plot ourselves another point. Now, because I want us to get, again, at least a minimum of 3 points, let's use the other name for it, -2 over -1, to get a 3rd point. Because I want you to make sure that you know how to use, other names for it too. So we can also go back to the y-intercept, and we have a choice of going down 2, which would be -2, and left 1, which would be -1. So we should end up with still a point that is going to help us be able to draw the line for this linear function. Now here's your ruler that you can use as a student to help you draw the line through the coordinate plane. So you don't just draw the line going through those 3 points and just kind of stop it like really quickly on either side of the point. Just draw the line all the way through the coordinate plane. Put arrows at both ends because why?
Because it goes
on forever. It goes on infinitely in both directions. How many points are really on this line? An infinite number of points. We just used 3 to help us get the graph, but there are many, many, many. If we put this in the graphing calculator, it would have an XY table that went on forever. We could pick out so many points that we would not want to have to even begin to have to graph them all. Okay, let's write the equation of that line. What's the equation of that line we just graphed?
y equals 2.
2x plus minus 3.
Okay, so y equals, we put the slope in front of the x, and it's a plus a negative 3, but we can clean that up and make it,
Y equals 2x.
we can just subtract 3 instead of making it plus a negative 3. Yeah, so we can clean it up. The equation of that line is y equals 2x minus 3. Okay, what I want us to do now is I want us to check 3 points from that line in that equation to make sure that we have a good equation. Plus, we also have a good line. So let's use the 3 points that we actually have there, okay? So let's write down our equation 3 times. Y equals 2x minus 3, y equals 2x minus 3, y equals 2x minus 3. Same equation, same line, but all 3 ordered pairs better make it true, okay? So let's identify the names of our ordered pairs. We have, we already know this one's 0, negative 3, right? That one's ordered pair 0, negative 3. What's the one above it? Up and off to the right. What's that one's name?
1 negative
1, ordered pair 1, negative 1. And the one below the y-intercept and down to the left. What's that one's name?
negative 4, 7 or something.
It's negative 1, negative 5, actually. Okay? Those are the ordered pair names of the 3 points we use to get our graph. So what we're going to do now is we're going to take those ordered pairs and we're going to substitute them into our equation that we wrote, and we're going to make sure that they check out. They should make our equation true if we have a good equation. So we have the ordered pair names, we have our equation, let's do our substituting in and see what happens. What's going in for y for this first one? 1 or negative 1? Negative 1. What's going in for x? Positive 1, and then we have our subtract 3. So negative 1 goes in for the y because that's our y value. 1 goes in for the x because that's our x value. So we have negative 1 equals 2 take away 3. Negative 1 equals, what is 2 subtract 3? Negative 5? Is that what I heard?
Negative 1.
Negative 1. Because we want it to be or because it really is? Because it really is. 2 take away 3 really is negative 1. That one checks out. Okay, let's do our next one here. We have ordered pair 0, negative 3. So there's our x, there's our y. We're going to put negative 3 in for y, 0 in for x, and simplify down until we have, hopefully, an equality. So negative 3 equals 2 times 0 is
0.
0.
Minus 3 plus negative.
And what is 0 take away 3? Negative 3. So negative 3 comes down here, equal comes down, and negative 3 because 0 take away 3 actually is negative 3, so it checks out. Okay, one more to check out. What are we going to put in for y from our last point? Going in for y?
Negative 5.
-5. What's going in for x?
Negative 1.
-1.
2 times -1.
So we have, let's bring down our -5 and our equal sign. 2 times -1?
Negative 2.
-2. So it's 2 below 0, the temperature drops another 3 degrees. What is it?
Negative 5.
This does become -5 over here, so that one checks out also. We're used to that. Yeah. So again, all of your points that are actually on that line better make that equation true. Or you either, if you start with the equation, you didn't graph it well, or if you start with, you got your graph and then you're going writing the equation for it and they don't match up either, there's a problem. We have to make sure that we understand all of those things go together. Okay? Put those rulers down, please. Any questions on this one? Any questions lingering over from yesterday when I wasn't here to answer your questions about slope-intercept form? Okay, then let's go to the back and see what we have to do back there. Okay, we're going to graph the line for the equation. This time they give us the equation. They say y equals -1/4 x minus 4. So, what's our y-intercept this time?
Negative 4.
-4, because we can rename this as y equals -1/4 x, change that subtraction to addition, and the opposite of 4 is -4. So our b value is -4, or in other words, that's where we're going to put a point on the y-axis, at y equals -4. And what's our slope?
Negative 1/4.
-1/4. Okay, this is important that we understand what that means. If it's a negative slope, how are we going to use that for rise over run? Aaron?
We would go down 1 and over 4.
Okay, so when we're graphing, we can make the rise negative, give the negative sign to the rise, so we would go down 1. But if we make that negative, then that means the run has to be positive. So then we're going to have a +4 as our run. So if you have a negative slope, either the rise or the run have to be negative, but they both can't be, right? Or, if we make the rise positive, then what would the run be? Negative. So we have the choice of going down 1 and right 4, or we can go up 1 and left 4. So we have both choices for when we use slope to get our other points. So let's go to the graph and put a point at our y-intercept first of all, -4 on the y-axis. And we're going to use both names. I want us to practice both of them. Because remember, we have to do 3 points altogether. So let's do the going down 1 from that. And if we go down 1, we've used up our negative. Now we're going to go to the right 4. Let's go back to the y-intercept again and use the other name, which says if you go up 1, you haven't used up the negative, so now you got to go left 4. So again, just like we talked about last week, we have to make sure the behavior of the line matches what we say it should be. If we have a negative slope, we better have a line that is doing what?
Going down.
Going down from left to right. Is our line going down from left to right? Yeah, okay, so draw the line through it if you haven't yet. And remember, it goes through the graph, through your points. Now, I'm not going to make you do these check problems for all of these. We were just doing that on the front to show you if you want to make sure that you do really have a good equation and or a good graph, that's what you could do, is you could put those ordered pairs into your equation and make sure that they check out, okay? But I'm not going to make you do that for all of the problems in the homework. That was just something we did in the notes. It's optional for you. Okay. Any questions left over from this one then? Something you didn't understand that we did? Okay, well, they don't always give us the equation in slope-intercept form. In other words, slope-intercept form means what? When you look at it, it better have what? What better be by itself and be only one of them? Y. You better have y equals. Does this say y equals? No, what form is this called? Anybody remember when you have x's and y's together on the same side and a constant on the other side? What's that form called? Is that?
Slope intercept form?
No, that's when y is by itself.
Doesn't have
It does start with an s though. No, it's not that either, not simplified. It starts with an st.
Standard.
Standard form. Standard form. Like the x's and y's are together on the same side and the constant is by itself. That's standard form. The standard form is handy for when you want to find the x and the y intercepts. You put in 0 for y to get the x-intercept. You put 0 in for x to get the y-intercept. Okay, but we want slope-intercept form. So we've got to get this equation, first of all, solved for y. You should have been doing some of that in your homework for today. So the first thing I want to do with this one is I want to rewrite it as add the opposite so that I'm more successful with it. I'm going to change that to instead of subtract 2y. And I suggest you do the same thing because trust me, this is where typically 9th graders, 10th graders, and even 11th and 12th graders go wrong, where they don't handle the subtraction well. So if I change it to add the opposite, maybe that'll help. Okay, I need to solve for y. What should be our first move? Aaron?
Subtract.
Subtract 3x. Okay, so we'll subtract 3x from both sides. And now we have negative 2y left alone on the left side. Are those like terms, negative 15 and 3x that we're trying to subtract from it? Are they like terms? No. So what we're going to do instead then is we're going to just write it as the subtraction problem, just write it horizontally instead. Negative 15 subtract 3x. We're going to stop right here and change that subtraction now to add the opposite also. Because again, this is where it will mess up if you don't. So let's change this to add. What's the opposite of 3x? Negative 3x. So before you even move on, just take the time to do that. It's painless. Okay, what's our next move? Yeah, we still don't have just y. We have negative 2y. What are we going to do?
Divide by 2 of everything.
Divide everything by 2?
Negative 2.
By negative 2, yeah. Let's divide everything by negative 2. So negative 2y divided by negative 2. Negative 15 divided by negative 2. Negative 3x divided by negative 2. Didn't have very many even numbers in there, so it's not going to be as nice as we probably would like it to be. But that's still, we can still do it. So our equation is y equals, these cancel out. What's a negative divided by a negative?
Positive.
Positive. 15 divided by 2?
7.5.
7.5. And since that isn't slope, we will change it to either a mixed number or a fraction. Or a decimal, I mean. I will change it to a mixed number. You can use 7.5 if you want. But that's our constant, so that's the one that we would like to know where it's at on the y-axis. What's a negative divided by a positive, or negative again? Over here we have
Positive.
positive. We have 3x divided by 2.
Whatever.
Would we want that to be 1 1/2 though x? Because it's slope. So what did I say we want to do with slope? Leave it as a simplified fraction. Don't change it to a decimal. Don't change it to a mixed number. Leave it as a simplified, improper, or proper fraction. So 3 over 2, can it be simplified anymore?
1.5.
No, we don't want to change it to a mixed number. We want to keep the rise and the run. So no, we're going to leave it as 3/2. And the x, when it's upstairs, can be pulled out beside it. And so we have 7.5 plus 3/2 x. Also known as, we can have those guys trade places. And so it'll look more like what we're used to, y equals mx plus b. Addition allows those two to trade places. So what's our m and what's our b? What is our slope?
3 over 2.
3 over 2. Or what's another name for that? So instead of going up 3 and right 2, what could we do?
Slope of 3 over 2.
We could go, instead of going up 3 and 2 right, we could go down 3 and
to the left.
2 left, so -3 over -2. We could make the rise and the run both negative. Whenever you have a positive slope, you can make both the rise and the run negative also. And then what's our y-intercept? 7.5 or 7.5, whichever one you named it. Okay, now this one you have to make sure you're not going to have a grid line that's a half. We're not going to change the scale on the y-axis to go by halves. We're just going to graph it halfway between 7 and 8 on the y-axis. So go up to 7, and then another half of a unit up, and graph yourself a point. So it'll be halfway between 7 and 8 on the y-axis as our starting point. Okay, now from that we could go up 3, 1, 2, oh, but we'll be off the coordinate plane, and do you really want to have to draw more lines? No, so this time let's not use the +3 over +2. Let's use the -3 over -2 twice. So we're going to go down 3, and we're going to be having to be halfway between still, and we're going to go left 2, so we're going to be right there. Down 3, left 2. You should be really at ordered pair -2, 4.5 for y. And from that point now, we can go down 3 again and left 2, and we'll have ourselves another point that will be not on an intersection of grid lines. It should be at ordered pair -4, 1 and 1/2. And we will draw a line going through our 3 points. With arrows at both ends, and say, do I like the behavior of the line I got?
Yeah.
It's rising from left to right, should it be?
Yeah.
Why?
Because the slope's flat.
Because we have a positive slope. If it has a positive slope, it should be rising from left to right. So if we put the equation in slope-intercept form correctly, then hopefully we have the right slope, which now the behavior of the line matches it, so we can feel fairly confident about it. You will use this method of graphing a ton from here on out. Whenever you're working with linear functions, you have to understand it and be able to work with it. So does anybody have any questions about any of it that we did here today? Okay. Then get out a sheet of loose leaf paper. Write down what the assignment is, and I'll get you your graphs handout in a bit here.